Okay, before we start our notes today, I want to show you guys this QR code feature on every single section. Anytime you have a number that's red in color, there's going to be a video explanation of that exact problem if you just open up your camera app and get the QR code on there. And then it says open in Safari. And it goes right to a video app. It's calcview.com. Slow service, of course. But that's how simple it is. So I'm not going to sit here and wait for this to load because I thought it'd be quick. Take advantage. If you're stuck on anything, QR code at 17 as well. Every section has a red problem to help you through with a video explanation. Okay, and they're pretty good. Oh, it came up here. CalcView, view the video. This guy right here is going to take you through how to do that problem. Okay. Okay. All right. So we left off on the second page of our 1.2 notes. So that's where we're going to be now. We're going to be working on finding x and y intercepts using a graph of an equation, and then also algebraically, and determining symmetry of graphs today. Okay. Now, when we find x and y intercepts, we're going to have to do some basic Algebra 2 factoring. And in tomorrow's learning targets, there's going to be some factoring involved. It doesn't get too intense, but at least enough where we should probably review this a little bit. All right, so you guys in class too, wherever you put your warm-up today, just try a couple of these review factoring problems before we get into this today, okay? So here they are. If you think you can squeeze it on a margin in your note somewhere, fine. I'm just going to give you two. If you can write small enough, go ahead. Okay, remember by factoring, the word factor means kind of break it down or do reverse multiplication. Okay, so strategies that you learned in Algebra 1 and Algebra 2 included GCF, or finding the greatest common factor that will come out of every term. Okay, that can be used in one of these problems. Other strategies involve taking a trinomial, like number 2, which is 3 terms, and breaking it down into 2 binomials, or 2 sets of parentheses. Okay, now when A is not 1, like a 2 or a 3 here, it gets a little more difficult. This is just A is 1. This should be a little bit easier for you. There's also a difference of 2 squares factoring technique you've learned. That's just some of those techniques. So I'm going to give you about a minute or two to see what you guys come up with, see what you remember from your Algebra 2 course. Okay? Go ahead, pause at home. Okay, that looked a little rough for some of you, so we're going to have to keep reviewing this. Expect the next couple of days to be more factoring for your warm-ups. Think reverse multiplication. On this one, there's a common factor of x squared, and there's a common numerical factor of 3. So if you're GCF, that's your kind of first step on this factoring problem. You have to identify it. What is it? 3 comes out, and x squared can come out. Okay? So what I think the best way to get through this is just put your GCF out in front of the parentheses, and now you just turn this into a game of fill in the blank. Meaning just, use the distributive property. 3x squared times what here would give me what's above. I just need x squared. Okay, let me transfer this minus down. 3 times what gives me 18. 6 x squared times what gives me x squared? Just 1, so I don't need to put 6 times 1. That's 6. That's my answer. Okay, completely factored. Every time you factor a problem, you can multiply it back out to see if you did it right. Okay, and make sure you take out the 3 and the x squared. Some people may just take out the 3 or just the x squared. Greatest, not just any common factor. Okay, 2, if we look for the common factor, there isn't one for all 3. So since all 3 don't have a common factor, this strategy is now gone. I'm moving on to something different. All right, so typically when you have a quadratic trinomial like this, second degree, 3 terms, we're trying to get it into 2 binomials. Okay, now sometimes there's different methods. However you're taught this, I don't care as long as you get it right. Factors of the last term is what you want to focus on right now. What are the factors of 25 that add up to 10? So if you think factors of 25, then you just kind of brainstorm some possibilities. Well, 1 times 25, that's a pair, and 5 times 5, that's it. All right, so the 5 and the 5 are going to add up to 10. So this is going to be the answer to this one. X plus 5 times x plus 5. Why does that work? Well, if we go back through and FOIL to check our answer, first times first, then outside 2 terms, I get a 5x. Inside 2 terms, 5x. Last 2 terms multiplied together is 25. And there you go. That's where we get the 10x from, right? So in the end, this is your answer. X plus 5 times x plus 5. Okay? All right, more of that review. So we need to be efficient at that. We can't be stuck on the factoring. It gets a lot more intense in Chapter 2, and we'll actually take a day or two to review some of this stuff. But we just need some of these basic skills like this in this section. Okay, let's transition back to our notes. Okay, locating intercepts on a graph is pretty easy to do. Just make sure you put them in the right spots. Okay, if AB is the points, x-intercepts, we always put the x-intercept in the first slot. So that's why it says A0. If you have a y-intercept that's B, we got to put that number in the second slot. Okay, and these diagrams just show you, you might have a graph that has no x-intercepts, no intercepts at all, or y. So you can have multiple intercepts in a graph, or none. Okay, so 5, it says identify the x and y intercepts from the graph. These are going to be in coordinate form on your multiple choice. So that's why I want you to write them in coordinate form so you put them in the right spot. So x-intercept at 2, 0, negative 2, 0. Right, so wherever it intercepts the x-axis, hence the name x-intercept. And where does this graph intercept the y-axis? Right up here at 0, 4. Okay, once you write those down, go ahead and try 6 on your own. Okay, there you go. There's your solutions. If this is a multiple choice, they probably wouldn't relist the 0, 0. All right, so we have 3 total intercepts, but the origin kind of counts as one of each. Okay. All right, now we can also find these by hand if we're given an equation, if we're given a graph. Just locate them and make sure you express them correctly. Okay, we're moving on to the next page. We're going to find intercepts now given an equation. Okay, so the first bullet says to find x-intercepts, let y be 0 and solve the equation for x. So we're going to replace y with 0. To find y-intercepts, it's just the opposite. We're replacing x with 0. And then we got to do the algebra. And that's why we reviewed Algebra 2 before we started, as you're about to see. Okay, let me walk you through this from scratch. I'm going to take you through 7 and 8, and you guys are going to try 9 and 10 here. Okay, so to find the x-intercepts, just like I said, we're going to replace y with 0. So I'm going to organize it like this. For y-intercepts, we'll just do the opposite. 0 goes in for x. So just my little reminder, and can separate it and organize it this way. Okay, so if y is going to be 0, the equation is going to look like this. 0 equals 2x cubed minus 8x. All right, we got to know how to solve this equation. Okay, it's not linear, so we can't treat it like a linear equation. It's cubic. There is possibility of factoring this, so that's what you want to do first. What can I take out of both of these? The numerical factor is 2. The variable factor is x. So we got to take out the GCF of 2x. Okay, just like that warm-up, just fill in the blank now. 2x times what gives me that? We need x squared. 2x times what gives me that? -4. Okay. All right, next we got to use something called the zero product law, which you were again taught again in Algebra 2. If you have a times b equals 0, then you say either a is 0 or b is 0. Because that's what's happening right here, right? To get a product of 0, like 6 times 1 is not 0. I need 6 times 0 equals 0. So one of these must be 0 or both. Okay, and that's what we have right now. A times b equals 0. So either a is 0 or x squared minus 4 equals 0. Okay, write that down. And now we just have to solve these two equations. Now this first one is linear, so this should be simple. We're going to divide by 2, undo that times 2, and we get x equals 0. This one you have options. We could use the square root method, or we could use the difference of two squares if you saw the factoring on that. You're probably not quite ready for the difference of two squares. So here we'd add 4 to both sides. So at x squared equals positive 4, and then we take the square root of both sides to get x equals plus or minus 2. Sorry, I'm kind of cramming in here. Running out of room, aren't we? Okay, so I actually have 3 x-intercepts. When y is 0, x is 0, 2, and negative 2. So it would look like this. I'm just going to write it up here, I guess. Squeeze it in. X-intercepts. 0, 0. When x is positive 2, y was 0, and negative 2. Y was 0. Okay? All right, y-intercepts. Y-intercepts are typically a little bit easier to find. Let me separate this with a line. Back to the equation. Y equals 2 times 0 cubed minus 8 times 0. And then just go through your order of operations, right? 0 cubed is 0 times 2, which is 0 minus 0. So y is 0. Okay? So that's our only y-intercept, which is we already kind of listed as the x-intercept. All right? Okay, so for the x-intercepts, you set it equal to 0. Look to see if you can factor it, if it's quadratic or cubic or above. Chances are you can probably take something out or use some type of factoring technique. Okay, let me take you through 8, and then I'll have you try a couple. Start with the x-intercept again. So we replace y with 0. Okay, now when it's a radical like this, we just have a different technique. We want to get this out of the radical. I can't add the x or subtract the 9 or do anything yet until it comes out of the radical. So what we want to do is square both sides. So basically we need to take 0 and square that, and take the square root of 9 minus x and square that. Why did I choose to do that? Because you got to remember, when you square a square root, those are inverse operations. They're going to cancel out. Like multiplying by 2 and dividing by 2 are inverse operations. We got rid of it. So that's why we're choosing to square in this scenario. Okay? So now we get 0 equals 9 minus x, and this is a lot easier to solve. Okay? Easier just to add the x to the other side. That way x is positive, and we have our solution. So if I add the x to both sides, we get x equals 9. There's my x-intercept, or 9, 0. Okay? Any questions on that one? No.